In this lesson, we discuss set concepts. So in this chapter, it's all about sets and the theory of sets. So let's start with a few definitions. For us, a set is a collection of objects, which are called elements or members of the set. One thing is important. A lot of times when we notate a set, we will use braces. This is a brace, and so these are braces, and we'll use braces many times when we are writing a set. All of the items or members of the set in here are called elements, and they're always going to be separated by a comma. A set is well defined if its contents can be clearly determined. For example, the set of, let's say, U.S. presidents. That's a well-defined set because the contents, which would be the presidents, can be named, right? Clearly named. Whereas a set of, let's say, the 3 best movies of all time, that's not a well-defined set because, well, what you consider the best 3 movies might be different than what I consider the best 3 movies, right? So that's not a well-defined set because the contents cannot be clearly determined. All right, there's 3 methods. We're going to go through all 3 in this lesson that we use to indicate a set. First is description. Next is roster form. And then set builder notation. Each of these are really important. Let's jump into the first example. Okay, so for this first example, this is an example of a description. Okay, and it's really, really simple. This first example says, write a description of the set containing the following elements: Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. Okay, so this is really simple, all right? A description would just be using words to describe what these elements are. Now, these elements obviously are the days of the week. So this set in description form would just be a statement that says, describing what the elements are. So the set is the days of the week. I mean, it's that basic, all right? So you're just giving a description of what those elements are. All right, so whenever now we're already moving on, all right, from description to, let's go to roster form, okay? Whenever we use roster form, we are using braces, like I said. So this is a brace. These are braces. And we always use braces whenever we use roster form. Now, this roster form, which is sometimes called set notation, is really important in mathematics. So let's look at another example. Okay, folks, example 2. Express the following in roster form. Now, whenever the text asks for roster form, that means we're using braces. Okay, set A, they want us to call this set capital A. Set A is a set, it should be the set, of natural numbers less than 6. Let's remember that the natural numbers are also called the counting numbers, and they include, or the set starts at the number 1. So 1, the natural numbers or the counting numbers are 1, 2, 3, 4, 5, 6, 7, 8, and so forth. So set A, this is the solution for the first part. Set A is a set of natural numbers less than 6. So this would be, let me call it A. Open up a set. So you have you're starting your brace. You're opening your set, and it will be 1, 2, 3, 4, 5. Notice that these are commas, okay? Kind of sloppy, but these are commas separating the elements. 1, 2, 3, 4, and 5 are the elements of the set, or members of the set. I use the word elements more. These are the elements of the set, and these are all of the natural numbers that are less than 6. All right, let's go to set B. Now, according to what they said, they want us to list out all of the natural numbers that are less than or equal to 45. less than or equal to 45. That means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and etc., right? So we're not going to list all those numbers. That would be too much. So we use an ellipses, ... right? An ellipses to say keep going all the way until you get to 45 and then close your set. So this is set B. So the ellipses here means that you continue the same pattern, okay, like etc. Okay, pretty simple, right, folks? The last part is they want us to use P to name this next set, and it's the set of planets in Earth's solar system. All of the planets in our solar system. So we have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. All of these should be capitalized. I don't know why I didn't capitalize Earth and Mars. Anyway, these are the all of the planets on our solar system. Don't forget Pluto. A while back, Pluto was kind of kicked out, wasn't it? It was reclassified as I think they call it a dwarf planet. So sorry, Pluto's not included here anymore. But anyway, this is an example of roster form. The big idea is that you're using braces and you are separating all of the elements by using commas. Okay. This next example is just illustrating the power or meaning of this word inclusive. All right. So the instructions say express the following in roster form. Set A is the set of natural numbers between 5 and 9. Between 5 and 9. That means it is the set 6, 7, and 8. Okay? We're not including 5 and we're not including 9 because they only ask for the numbers between 5 and 9. Whereas the second question or objective is to list the set of natural numbers between 5 and 9 inclusive, meaning we're supposed to include 5 and 9. So 5, 6, 7, 8, 9. So a pretty simple concept here. Just be careful with language. If we're saying inclusive, that means we're including the endpoints, right? 5 and 9 are now included. All right, some notation here. This symbol here, you see that symbol there? This, I don't know if you've seen this before, it means is an element of. So let me show you how we can use it. I can say 8 is an element of set A. So if I don't want to write that out in English, right, I can use this mathematical notation to say 8 is an element of A, set A. In other words, 8 is listed in this set. I could also say 8 is an element of set B because 8 is also in that set. Now, we may also write, let me move this up just a little bit, 8, or rather, I'm sorry, let's say 5 is, watch this, not an element of set A. 5 is not listed in set A. So this means 5 is not an element, right? It's not part of set A. So you're going to see this symbol a lot, so you may want to get used to writing that out. Okay, folks, we've talked about description, we've talked about roster form, and now let's talk about set builder notation. Let me just show you an example of set builder notation right away, and then I'll translate it for us. So this would be set builder notation. It would be set E is, and it doesn't have to be named E, okay? And you can name your set whatever you want. I just chose that letter at random, okay? But set E is the set. So the way you read that brace is the set of all elements X such that X is an element of the natural numbers. Sometimes that is written more boldly, so like this. That's like I did a poor job, but that's like a bold N. Here, I'll just write, that looked too sloppy for me. So that's a bold N there. That means natural numbers. And X is greater than 10. So this is an example of set builder notation. So of course, this is the name of the set E. The equal sign is translated as is. The set of, that's how you read the brace. All elements X, and it doesn't have to be the letter X. You know that it can be we choose any symbol or letter to represent our variable. And then this like vertical bar here means such that. Now, all of this here, let me change colors here. All of this here would be the conditions. Okay, this is the conditions. So you want all natural numbers only that are greater than 10. And this is strictly greater than 10. So it's not including 10. So basically in roster form, so that was set builder notation. In roster form, your set would start at 11 and then 12, 13, 14, and ellipses for etc. This is an infinite set because there are infinitely many natural numbers that are greater than 10. And so of course we're not going to list out all the numbers. That's impossible. So that's why we just use like the etc. or ellipses here. Anyway, this is set builder notation up here, and then this is roster form. Okay, next example. Write set B, which is equal to the set 1, 2, 3, 4, 5 in set builder notation. Okay, so they gave it to you, this set called B, in roster form. So they want it in set builder notation. All right, so then it will be like this. B is equal to the set, okay, of all elements X. I don't have to use X. I could say all elements Y, all elements Z, or whatever, right? Such that. Now, you're going to have to look at these numbers, 1, 2, 3, 4, 5, and what kind of numbers are these? Like what are these elements? Well, they're all natural numbers. So we're going to say X has to be a member of the natural numbers, but not just any natural number. It has to be any natural number that is less than 6. So we have to add to the conditions. So we say and X is strictly less than 6. Now, this is not the only way to write it. You could say, instead, you can say the set B is the set of all elements X such that X is a natural number, X is an element of the natural numbers, and you can say it like this, X is less than or equal to 5. So that's another way to write it. This here is inclusive. It's including 5. This here does not include 6, right? So there's either way is acceptable. Okay, part B says write in words how you would read set B in set builder notation. So basically they just want to make sure that what we're writing we also understand, right? And understand how to basically share that language and how to say it out loud, really. So set B is the set of all elements such that X is a natural number and X is less than 6. That's how you would read this in words, basically. And of course, this is the same way. Set B is the set of all elements such that X is a natural number and X is less than or equal to 5. All right, check out this example. Write the following set in roster form. So this form that they gave you the set in is set builder notation. And so in roster form, first, let's read this out loud. Set A is the set of all elements X such that X is a natural number and X is between 2 and 8, X is between 2 and 8, inclusive of 2, but not inclusive of 8. All right. So then in roster form, we're just going to list out these numbers. So then here it is. A is the set of the following elements. 2, so you include 2, and then 3, 4, 5, 6, 7. Don't include 8. Okay, this is a true or false kind of example. Determine whether each statement is true or false. All right, blue. The element blue is an element of this following set. Is it true? Yes, it's true because blue is listed in the set. Therefore, this blue is a member of the set. So this one's true. It's that simple, folks. Basically, do you see blue inside this set? Yes. So it's definitely an element of the set. Peppermint. Is peppermint listed in this set? No, it's not. Therefore, peppermint is not an element of this set. So this statement here is false. This really should read, peppermint is not an element of this set. Now, this one could be tricky because this does not say sapphire. This says the set sapphire isn't an element of this set. So I see sapphire, but I don't see the set sapphire. So in other words, this statement is false here. What would make it true, folks, is if you saw the set sapphire in this set. In other words, if the set was written like this, then it would be true. Because inside of this set, I see the set sapphire is included. So it's just a play on language, okay? So be very careful. This says, is the set sapphire included or listed in this set? And the answer is no, okay? All right, so we're going to wrap up this lesson with some definitions and maybe another example or two. All right, so some definitions, quite a few, right? A set is said to be finite if it either contains no elements at all or the number of elements in the set is a natural number, okay? Like, for example, the set we listed earlier, the planets of our solar system. That was a finite set. A set that is not finite is said to be infinite. For example, the set of natural numbers or counting numbers. That's infinite because the list goes on and on, never stops. Okay, what does it mean for two sets to be equal? A set A is equal to set B, symbolized by A equals B, if and only if set A and set B contain exactly the same elements. Now, the cardinal number of a set, okay, and this is how we write it. So this is N, and then in parentheses is the name of the set, okay? So if we're talking about set B, then right here would be B, all right? But it's simple. The cardinal number of a set is just how many elements are listed in the set. So if, for example, the set we're talking about is the months of the year, January, February, March, April, May, June, July, August, September, October, November, December. That set, the cardinal number would be 12 because there's 12 months in a year. There's 12 elements in that set. So the cardinal number of a set is just how many elements are in that set. Okay, set A is equivalent to set B. Now, equivalence does not necessarily mean equal, okay? Equivalent means same value. That's the definition for that word. But in set theory, set A is equivalent to set B if and only if they have the same cardinal number. In other words, set A and set B are equivalent if they have the same number of elements. If set A has 5 elements in it, set B has to have 5 elements in it as well if they're going to be equivalent. Now, they don't have to have the same exact elements, but they have to have the same number of elements. In other words, set A and set B don't have to be equal, in order to be equivalent. Okay? They don't have to have exactly the same elements. They just need to have the same number of elements if they're equivalent. Okay, the empty set or the null set just means there's no elements in the set. It's empty. Okay, and so this would be your way of saying the empty set. It's a set of braces and there's nothing inside. Okay, or this symbol here, which looks like a 0 with a slash through it, which is the reason why in every math class you never want to use this symbol to represent 0. Okay, 0 is a whole number, but this notation here doesn't mean 0, it means the empty set. Okay, finally, a universal set, we use capital U to represent a universal set, is basically just a set that contains all the elements for any specific discussion. So whatever we're talking about within the context of the problem, U just represents the set that contains all the elements that apply to that conversation. Okay? All right, check this out. Indicate the set of natural numbers that satisfies the following equation. Okay, so the only value of x that makes this statement true is the value of x that is the opposite of 2, right? Whenever you add opposites, you get 0. And so the only value that satisfies this equation would be -2. However, so I'm tempted to say my answer is -2. That's the set of solutions. However, -2 is not a natural number. Remember, natural numbers are only counting numbers starting at the number 1, and then it goes up from there. So therefore, the solution set is the empty set. You can write it one of two ways. So it's the empty set or the null set. In other words, there's no solution for this equation over the natural numbers. Okay? All right, I hope you learned a lot, hopefully, or maybe even just a little in this short lesson.